What's up, guys? Dylan Codes here, and welcome to day 19 of Advent of Code 2020 in Python. Sorry this video is coming out late. I have to admit this one took me a while to solve, but let's go ahead and get into the solution, see what we have here. So let's see, day 19. We land in an airport around a dense forest, and we've collected an image of a sea monster, but the satellite's having problems and the image is corrupted. So we have the rules of valid messages we should obey and a list of received messages. And so basically the messages here are to concatenate strings. So for rule 0, message, we do rule 4, so we put an A. And then for rule 1, we can have we have rule 2 concatenated to rule 3, or rule 3 concatenated to rule 2. And so what's rule 2? Well, rule 2 takes 4, 4, or 5, 5. So rule 2 will return AA or BB. And rule 3 will return AB or BA. So we have here we have any combination of AA, AA, AB, or BB, AB, or so on, because we have these combinations here. And so I think we're going to solve this recursively, at least for part 1. I'm just going to find all of the possible combinations that match this first one, and then for our list of messages, then we will see if the messages are in the allowed strings. So let's go ahead and get into it. Well, let's grab our puzzle input first. Control A, Control C. Okay, so as always, we're going to say with open input 19.txt as file, and data is equal to file.readLines. And then we will say data is equal to line.strip for line in data. And now we are going to parse out the rules. So if you see here, we have in our rules, for example, we have a rule number and then a colon. And then we're either going to add these two or we're going to add these two. So I'm going to make a dictionary where the key is the rule number, and then the value is a list, and the list, and then so the list, there's one big list, and then we'll call this an option and this an option, and then each option will be its own list, if that makes sense. So I'll kind of type it out and then show you what it looks like. Okay, and before we get started with parsing out the rules, first we're going to put all the rules and all of the messages in their own list. So you can kind of see here that we have this blank line that separates out this file. So we are just going to say rules data is going to be equal to just data, and then we're going to take everything up to the index of the blank line, and then messages will be equal to data, and then we're going to say data.index blank line plus 1. So that should separate everything out there. So now we'll say for rule in rules data print rule, and we'll say for MSG in messages print message, and you can see what we get here. And this should be like so. Okay, so now you can see all of our messages here at the bottom, and then our rules are up top. Okay, so now we can parse out the rules. So we'll say rules is equal to a dictionary, and we'll say for line in rules data. Then we'll say line is equal to line.split at the colon space. So now, and we'll say now rule num is equal to int line 0, because yeah, that'll be this part. And then what's left is this string here. So now we'll split this string with the space bar and then space. So now we'll say line is equal to line 1 dot split and then we'll say for option, here, we're gonna call this options. Options is equal to line 1 dot split, and then for op in options, we will have, well, let's call this option string, and then we'll say we'll have a list here called options, and then we will say for op in option string, options dot append, what the heck, options dot append op, and then at the very end here, rules rule num will be equal to options, and then we will say for ij in rules dot items print I comma j, and then you guys can see here, if we go down to the bottom, then for each rule we have the options separated out. So then we have here and here, and then here and here. And I want to take this even further, and we're going to say options dot split. So then if we run this one more time, now we can see that each option is in a list, like so. Okay, so it's a list of 2 lists where each of the inner lists represents an option, and the indexes here represent the rule numbers for that option. So now we are going to write def solve1. And so basically what I'm going to do is we're going to start at the rule that is rule 0. We're going to start here, and then we're basically going to recursively go through until we hit a rule like 122 where it's just an A. And then from there we can start building things back up and combining. Kind of confusing, but let's go ahead and see what we can do here. So the first thing that we are going to do is modify this to take in a rule number, and we will say that the rule options are equal to rules of num. So for example, for rule 0, rule options will be just a list of 8, 0. So then we will say if A in rule options, so this is the base case here, return A. If B in rule options, return B. So now we'll do the recursive case. So now we're going to say we'll have a final list of strings to return, and then for option in rule options, and I'm going to kind of code this out here, and then I'll explain it at the after I'm done typing it out. So for rule and rule options, then we'll have a list called string options. That'll be equal to a blank list. And then for each rule in an option, then we'll have the substrings, the sub options to append. And so you can see here, if our rule is equal to 20, then okay, let's go here. So if our rule is 94, actually I like this example better. If rule is equal to 6, then rule options is equal to this big list. And now each rule within rule options, each option is here. So here's option 1 and option 2. So we're going to do everything here for option 1. And then we'll do it again from option 2. And now for the rule within the option is this. So if this is our option, then our first rule is 88. And then we're going to add 122 to the stuff from 188. Okay. And we're going to say the sub ops is going to be equal to solve1 of int rule. So basically what this does is it's going to go in and it's going to say, okay, so for example, for 0, I believe, yeah, so 0 was 8 and 11. So 0 comes in, and then we'll say, okay, now we need to add everything in 8 and everything 11 together. So first, get everything from 8. So get everything for 8 first, and then we'll say if length of string options is equal to 0, then string options is going to be equal to sub options dot copy. And we'll do dot copy just to be safe so nothing gets erased. Okay, so this was the case that we're in the first number of the option, but what if we're in the second number of the option? We don't want to erase the stuff from the previous one, but we want to append it to the end of it. So then we can say else. We're going to have a list of combined options. So combined is equal to that. And then for, we'll just say for S in sub ops for, and then we could say for option in string options combined dot append option plus S. So what this does is for every single, so we have everything that could be in the first one, and then we need to find every combination of adding all the options for the second number to all the options of the first number. So that's going to be a huge whole long list of combinations, and so that's what this loop will enable us to do. And then we'll say combined, so that'll go into combined. And the reason why we do it in a separate list here is we don't want to overwrite the stuff in here, and we don't want to overwrite the stuff in here, because final will contain all the combinations from this first option and the combinations from the second option. So we don't, if we're on the second option, we don't want to overwrite anything from the first option. And so now we will say string ops equals combined dot copy, and then final plus equals to string ops. And then at the very end, we can return final. I think that'll work. And then, but there is the case that we could be reusing certain numbers. Like you could see 54 shows up here and here and here and here. And we don't want to spend the time redoing it if we've already figured it out once. So then I'm also going to say up here, string rules is going to be equal to dictionary, and then the first, and then if we've seen the number before, so if num in string rules, return string rules num. And so this is if we have seen it before. If we haven't seen it before, then this is the first time we're seeing it. So we'll say string rules num is equal to final. So that way we don't have to find that particular number again. And so now we can say all possibilities is equal to solve 1 with the starting point of 0, and then we have to check a lot of strings. So instead of looping through this list every time, I'm going to put those into a set. So for a in all possibilities, and we're going to say all set dot add a, and then we'll say count is equal to 0, and for message in messages, if message in all set. And the reason why this is faster is because if we just did all possibilities, it would have to loop through all possibilities for however many messages there are. But if we check if it's in the set is O of 1 runtime because it's all hashed. So there's no looping there. So if message in all set count plus equals 1, and then we'll go ahead and print count. So let's go ahead and see what that gives us. 279. Fingers crossed, right? Okay, so there's the answer for part 1. So part 2, let's see what we have here. So now, as we look over the list of messages, we realize our matching rules aren't quite right. So to fix them, replace lines 8 or rules 8 and 11 with, so that means it can loop because we have either 42 or 42 and 8. So we can go 42, 42, 42, 42, or, and then this can loop too. So only handle the rules we have. So, okay, let's see what we got here. All right, guys, so I have to admit on this part, I have been pretty stuck. And so my original plan for this part was to incorporate the rules, let them loop a couple times, and kind of utilize this rules here that we kind of did in our recursive solution. It's basically the same thing where I was like trying to find all possibilities for like if we let them loop 3 times, and well, it kept running out of memory, so that wasn't going to work. So kind of had to come up with a different solution here. It's kind of a different approach. Fortunately, the stuff from the first part didn't go to waste, but we'll be kind of utilizing it, but the second part's not going to be like the first part. So I think the first thing to understand here is that we can have strings that, we can have strings that look like this form, 42, and that's from rule 8, we can have 42, and then from rule 11, we can have 4231. But this part can loop, this part can loop, and this part can loop. So really, we could, for example, we could have 42, 42, 42, 42. This is all from rule 8. And then we're going to move on to rule 11. Then we could have 42, 31. Well, this 42 from rule 8 could also loop. So what if we just did 42? From rule 8, we do 42. And then from rule 11, we could have 42, 42, and then 31, 31, 31. But I believe it is the case because of the nature of this pattern here that there will be less 31s than 42s. So basically, for each string that we have, for example, if we have like A, B, just like all that sort of stuff, say, for example, that this portion is from 42. Then the remaining then this portion is in 42, and then this portion is from 31. So we can check, we can break the strings up into portions, because a string from 31 is going to be the same length as a string from 42. So we can break the string up into equal portions and then test if it's part of 42 or 31 or in neither. So let's go ahead and start writing that out. So we're gonna have def solve 2. No input parameters this time. And let's go ahead and get, so from this string rules here, we already know the list of possible strings for rules 42 and for rules 41. So let's go ahead and say R42 is equal to string rules 42, and R31 is equal to string rules 31. And then we'll say for R in R42, print string rules. Oops, just kidding. No. Print R. And for R in rule 31, print R. And so if I go ahead and print those for you guys, then you can see that indeed, oops, what? Misspell. You can see that indeed that all of these are the same length. So rules from 31 and 42 are the same length. So we're gonna say that the size of you can call this a chunk. So we'll say chunk size is going to be equal to length of R42, and we'll just say 0, the first one. So if we go ahead and print chunk size, you can see that the length is 8. Okay, so that's good to know. Move that up. And so now we are going to say, we're going to keep track of, basically, we're going to, instead of looping through all the possibilities, we're going to loop through each string and just see if it matches a possibility based off its chunk. So we're going to say for message in messages, then we will break the message into chunks. So we're going to say chunks, and so we're gonna have two lists, and one will be the chunk. Both strings or both lists will have booleans, true or false, and they'll be the same length. And the chunks 42 will represent if that chunk is from rules 42, and chunks 31 will represent if that string is from here. So we'll say false for blank in range length of message divided by the chunk size. So because these are equal length, then it's guaranteed that, for example, if this, well, we saw this length is 8. So if it has 3 chunks, then the total length is 24. If it has 6 chunks, then its length is 48. So this is basically getting us a false for each chunk within the message, and then false for blank in range length message divided by chunk size. Okay. So now we have to update these chunks. So we will say that our current chunk is equal to 0, because that's index 0 of this message. And we will, oops. And so now we will check each chunk. So we're going to say for I in range length, well, 0, length of message, and then we're going to give it of increments of chunk size. So what this will do is, you can see here, if I were to do 0 to 20 with a increment of 5, you can see it increments by 5 each time. So that's kind of handy. So we'll say if message, and we want the part of the message from I to I plus chunk size. So what this will gives us is, if we're checking the first chunk, that'll be 0 to 8. If we're checking the second size, then that'll be 9 to 16, and so on, or something like that. If if that's in our 42, then chunk size, not chunk size, then chunks 42 of our current chunk is equal to true. If message, and it should be in either one or the other, so this will be okay. If message I plus chunk size is equal to, or in R31, then chunks 31 is going to be equal to true as well. Just kidding. Chunks 31 at the current chunk location is equal to true. And so now once that runs, and then once it goes, then current chunk plus equals 1. Okay, so this part will determine which chunks come from which rules. And now we will, for that message, we will determine, does this message match the rules? So we're going to basically determine how many chunks are true and how many chunks are false for each one. So count 41. So, okay, we'll say count 42 is equal to 0, and for well, creative name here, we'll say for chunk in chunks 42, if chunk, then count 42 plus equals 1. So that if it's true, then plus equals 41, and count 31 is equal to 0. And for chunk in chunks 31, if chunk count 31 plus equals 1. And then we'll say if 0, and remember we said we want there to be less of 31 than of 42, then we can say that this is a good this is a good chunk, so count is equal to 0. And then we'll say count plus equals 1. I guess I'll make this a little more readable. And then at the very end, return count. And so hopefully this works here. So we'll say C is equal to solve2 and print C. See what we get. 407. Let's go ahead and try it. and the answer is too high. So let me make some modifications here. Okay, and I think I know what the issue is. So I want to go ahead and make modifications because I guess this doesn't check that the chunks come in the correct order. So we are going to check that they do come in the correct order. So let's get rid of this for now. So we'll say count 42 is equal to 0, and count 31 is equal to 0 and 0. And then we'll say that our current per chunk, once again, is equal to 0. And for, well, we'll say if message, or not if message, if chunks 42 per chunk, so it has to start with a chunk from 42. So if per chunk is equal to true, then we will say that count 42 plus equals 1 and current chunk also plus equals 1. And then we'll say while current chunk is less than length of chunks 42. So obviously we don't want it to go too long because we're going to be incrementing it each time. While current chunk is less than length of 42 and chunks 42 of current chunk is equal to true, then count 42 plus equals 1 and current chunk plus equals 1. So now as soon as, so this will be true either while all the chunks are in 42, but if it suddenly becomes false, then now let's start checking for chunks 31. While current chunk is less than length of chunks 31, and this will be the same length as chunks 42, and chunks 31 of cur chunk is true, then count 31 plus equals to 1, and current chunk also plus equals 1. And then, so we're going to run this. So while we have chunks from 42, increment count 42. And then once we don't have a chunk from 42, increment the chunks from 41, or from 31. And then once we don't have a chunk from 31, we're going to check if current chunk is equal to the length of chunks 31. And 0, this is like before, we want count 31 to be less than count 42. Then total, I guess we called it count, plus equals 1, and now return count. So let's go ahead and solve this one more time. 384. Let's go ahead and try it. All right, and there you have the solution for day 2. So once again, I apologize for having this video out so late. It was very difficult. I had to change up my approach, and hopefully I will be able to get day 20 out sometime later today. Other than that, I'll see you in the next video. Drop a like if you enjoyed.